Thank you very, very much. Some of you saw Thomas last night, and today I think we had a lot more detail, and you managed to convey that quite clearly, I think. I just want to say a few words before we start with the questions. Just to put a bit of a frame on today's discussion, today's topic is primarily, I say, on the science of climate change. What we are talking about here today should be around the issues of the natural sciences and the report on the physical science basis. The fifth assessment report, as many of you know, consists of 4 parts, and the next 2 reports will deal with the impacts, adaptation and vulnerability, that's part 2, and then the third part of the fifth assessment report is on mitigation and emissions reductions and so on. Maybe we'll have new seminars then. The purpose of today's seminar is that we all learn a bit more about the science of climate change and that we have a better understanding of these issues when we leave the room. And for now, if questions come up that Professor Thomas Stocker is not quite comfortable answering, it's outside his area of expertise, something which I doubt, but it could happen. We'll try to pick up the questions later today. And I also wanted to say that in the next part, after this first break, we will have 5 presentations. And one of them will deal with specifically about the temperature development for the last 15 years. And also there's a presentation on the oceans, and there's one on ice and the polar regions. So it could be an idea if we hang on to those questions until the next part. Now, questions from the room. There's one here. Wait for the microphones to arrive. That's important because of the webcast and the rest of the crowd. There's one coming down here right now. And say your name and be reasonably brief.
Okay. Tormod Skei, thank you for a very interesting presentation. One question is just, have you dealt with tipping points, and how have you dealt with them, if you have written about them?
That's right. The topic of tipping points is actually dealt with in Chapter 12, which says long-term climate projections and irreversibilities, because many of these tipping points also show irreversible changes to the climate system. Obviously, this is a difficult topic because projection of where these tipping points are exactly on the time axis and whether or not these tipping points are achieved and reached, that is a hard scientific question. But you have seen one of these points, if you accept that the disappearance of September sea ice is a tipping point. We are now much further advanced in our capability to actually identify that. I personally wouldn't call that a tipping point, although for the ecosystems in the Arctic it clearly is. But it's basically a continuous development of a physical quantity that goes through the melting point of water. A similar tipping point, but again also a continuous development concerns ocean acidification. So the areas where we go undersaturated in calcium carbonate and therefore have conditions where the organisms in the ocean have more difficulties and are challenged to actually form their shells. That is something that is also newly calculated with the models that we have available. More of the classical tipping points, such as the northward extension of the Gulf Stream, for example, there is not much new material in our report. We basically reconfirmed the findings of the 4th assessment report. In other words, this circulation reduces over the course of the 21st century, but we are not quite sure whether the model simulations and the climate models actually capture all the relevant physical processes that allow us to make a high confidence statement whether or not that circulation will collapse in the 22nd century, or whether it will recover to a new type of equilibrium on the long run.
Hands up. There's one.
Thank you. Per Anker Nilsen from the Confederation of Norwegian Enterprise. I want to, if you can elaborate a bit about the pause of the last 15 years. What you say now is that the energy has gone down in the ocean. Being by many things also a marine zoologist, I remember some of what I learned at university, that the ocean is a very, very big mass of liquid that moves very, very slow. And if you have surface water in the Arctic going down between Greenland and Iceland, it will appear on the surface 500 years from now. So, and also I noticed that you talked about an ocean heat rise of like 3 digits, was it? 1/100th of a degree. And I also remember from my courses that we don't really have any good measurements of the ocean. Yes. So, and you said yourself, where has the heat gone? So, if the heating has stopped in a period where, for instance, China has emitted more CO2 than ever, and the emissions have gone extremely high, there's been no warming in this period. Where did the heat go before? And where does it go now? And I'm not convinced that you have, at least you have not convinced me, that you have a good explanation for how the heating process suddenly has gone from the atmosphere into the ocean. And if that's the case, why didn't the ocean heat prior to this?
Right.
Thank you.
Thank you.
As has been mentioned, this will be a topic of another talk by, I understand, Peter Thorne. Later on, or by Einstein? Okay. But I can say only so much. Heat is not only taken up by some slow circulation of the ocean, the heat is taken up worldwide by the ocean. It's penetrating at almost all latitudes of the ocean. And this is one of the few physical processes that we understand really well and we can quantify. Now, you mentioned the small temperature changes. I'm only referring to the 15 years. For 15 years, if you say that you would like to find the heat of the 15 years in the deep ocean, then it's a couple of hundreds of degrees Celsius. That's the estimate, and that is beyond the measurement capabilities. But what you see here is not over 15 years, it's over 40 years. And over 40 years, the temperature changes that are measured in the ocean are precise enough to show actually this figure of changes in energy. So we're talking about 40 years. We're talking not here about the last 20 or 15 years here, where there are large uncertainties. And then I should also say the increase in temperature, people only look at these 15 years, but if you go back in the record and actually make an analysis of other 15-year periods over the last 50 years, then you see that there is a lot of natural variability in the climate system, and it's simply not appropriate. And everybody of us has learned that actually many years ago in geography. If you talk climate, you talk 30 years or longer, and not 15 years. So that has to be kept in mind. I would say, in conclusion, it's a very interesting scientific question, and which we need to resolve, but it's not something that is able to nullify a very coherent understanding of the climate system, which again doesn't only consist of atmospheric temperature, but it consists of all the observations and the physical understanding and the fitting together of the picture of melting ice, of melting Greenland, of melting Antarctica, of taking up heat in the ocean, etc., etc. But again, read the 2,000 pages and perhaps you will think different.
Or maybe we'll actually come closer to the solution later today. We'll come back to this. I want to take the opportunity now to pose a question, and it's something that people have asked about. I would like you to go back to the carbon budget slide. And I think it raised a lot of eyebrows yesterday. This is quite interesting. And you end your talk by saying, we have a choice. Now, some people in this room wonder, do we really have a choice in terms of the 2-degree target? Are we actually able to reach that? You said we spent 500 gigatons. You showed us a graph saying we have maybe 800 gigatons to go, 300 left. Is the 2-degree target really realistic?
That's a difficult question. As a scientist, I say, yes, it is still a realistic target. As an economist, which I'm not, you may say, no, it's not a realistic target. But it's Working Group 3 of IPCC who looks at that aspect of the feasibility of targets. There are also physical aspects of feasibility of targets. If you accept the notion of a finite amount of carbon to be emitted, once you have said you want to limit climate change at 2 degrees, then you realize that there is a clear, you could even say, tipping point at which you can no longer achieve that target unless you actively remove the carbon dioxide again from the atmosphere. And that point where a climate target becomes unachievable, that point is actually quite close. And you can do a back-of-the-envelope calculation. You can even do it in your head. Considering methane and other greenhouse gases, we have 800 gigatons left. We have 800 gigatons in the pie. We have emitted 500 gigatons, so we have 300 gigatons left. We are now emitting 10 gigatons every year, and it's optimistic to say that this number doesn't go up, but assume it doesn't go up. 10 gigatons every year, 300 gigatons left, so it's 30 years. So it's a few decades, if not less, that determines whether or not a climate target is still achievable. Now, the assumption that I made is that with the 30 years is that you continue to emit 10 gigatons every year, and in 30 years you say, now it's over. That's clearly unrealistic that we could stop the emissions from one year to the next. So you're talking about different pathways that spread the remaining pie not only over some longer time, but also among more participants, among more eaters of the remaining pie. And we know who eats and who has a big appetite of that pie. We've seen it yesterday in one of the presentations of the minister. So it's a challenge, but I would not be able to tell you, no, 2 degrees is not feasible. From a physical point of view, it is feasible, and we do have a choice indeed.
Thank you very much. It's 10:15. We're going to have a break, just a few practical things before that. We will switch to Norwegian after the break, but we have interpreters here. Anyone in this room who needs a headset for the interpreters, you can get it at the back of the room, and it's channel 1. If you do have questions you want to put in the boxes, do that. And we'll open the windows in the back of the room so you can go out and get some fresh air, and there's some coffee. We'll see you at 10:30. Thank you. Yeah.